All right, this is problem number 12 from chapter 4 of the Holiday and Resnick book. So here we go. It says, at one instant, a bicyclist is 40 meters due east of a park's flagpole, going due south with the speed of 10 meters a second. Then, 30 seconds later, the cyclist is 40 meters due north of the flagpole, going due east with a speed of 10 meters a second. And then we got to find out some stuff about, sort of what's going on here with the cyclist. So let's draw it. All right, it sounds like everything is measured in relation to this flagpole. So let's draw ourselves a little coordinate system. So we'll have the center of the coordinate system here be the flagpole. So our first sentence here says that he starts out 40 meters due east of the flagpole. So let's just go 10, 20, 30, 40. So he's right here. So here's our x-axis in meters. This will be our y-axis, also measured in meters. And it tells us that he's going due south with a speed of 10 meters a second. So here's what we just learned. We know that our initial position, that's an R, R0, is 40 meters along the x-axis, the I-axis, right? And at the instant, our velocity is negative 10 meters a second on the y-axis, right? Okay, so that's that. Now, it also tells us that 30 seconds later, he's 40 meters due north of the flagpole. So 10, 20, 30, 40. He's right here, and he's going east now at 10 meters a second. So what this is telling us is this, that our position after 30 seconds is 40 meters, but along the y-axis, and our velocity at that same instant is still 10 meters a second, but now it's along the x-axis. Okay, so that's the information. So I don't know this for a fact, but my guess is that the cyclist is kind of, riding in a circle around the flagpole. All right, and so that's what's going on. And so we've got, at this starting point, we've got this red position and red velocity vector, and then 30 seconds later, we've got this blue position and blue velocity vector. Okay, so that's kind of our given information. All right, so let's free up some space here on the board. Hopefully that's big enough that you can still see it. All right, and so now we're going to see if we can solve some of this. So question A says, what's the displacement? So remember, now that we're working in more than one dimension, obviously we're using r for position, and so displacement is going to be change in r. So change in r is, it's our final position, which for us is the position after 30 seconds, minus our starting position, which is r0. So I'm literally just going to plug in my numbers. Let's see, r0 was, r30, our position after 30 seconds was 40j meters, I'll put that in a minute, minus our starting position was 40I, right? And this is all in meters, right? So this is a little weird. I've got my coordinates flip-flopped, right? Usually we do ij instead of ji, so I'm just going to rewrite this as negative 40I, that's my x component, plus my y component, and that's all in meters, right? Okay, so great. So this is our displacement in unit vector notation. Here it wants it in magnitude and direction notation. All right, so but look, all this is telling me is that the cyclist traveled 40 meters left and 40 meters up. So let's draw that. So he's started out here, that's his starting position, and he went 40 meters. That's my horizontal displacement. Vertically, he went 40 meters. And we're looking for this. So all you're going to do is you're going to do the Pythagorean theorem. So we know this is a right triangle. And then find your angle. And we can see pretty quickly that since these two sides of the triangle are equal, this has to be a 45, 45, 90 triangle. So I know this angle here is 45 degrees. So do your Pythagorean theorem. That'll give you your magnitude. And then the direction is 45 degrees north of west. Okay? And you can see all of this on the drawing, right? It's that black triangle that I drew here. Let's see if it'll let me move this thing. That is just this, right? Okay, so there we go. All right, so that's part A. Now, for part B, let's clear up the board a little bit here. Well, no, I guess I want to keep this. I want to keep all this stuff. So, yeah, let me shrink this stuff down. Okay, so for part B, it says find the magnitude and the direction of the average velocity. Well, remember, average velocity is, by definition, displacement divided by time, right? Well, we just found our displacement. It was 56.6 meters, right? And that took us 30 seconds. So divide it out, and you get 1.89 meters a second. And then the direction is in the same direction as the displacement. So we averaged 1.89 meters this way every second for 30 seconds. All right, so that's all there is to B. All right, and then finally C asks us for the average acceleration. All right, so C, find the average acceleration. Well, average acceleration is change in velocity divided by time. So for us, that's VF minus VI, or it's our final velocity minus our starting velocity. So for us, that's our velocity after 30 seconds minus our starting velocity divided by the time. Okay, sorry, I'm being terrible about my arrows for velocity. Okay, so our velocity after 30 seconds, well, we know that. That's right here. That's 10 meters a second in the I direction. And then our starting velocity was negative 10 meters a second in the J direction. So I'm going to go minus negative 10 meters a second in the J direction. And all of this took 30 seconds, right? The idea is our velocity went from 10 meters a second this way to 10 meters a second that way. We got to find the acceleration. So 10 minus a negative, so that gives us 10I plus 10J meters a second divided by 30 seconds. And then divide it out. So you can just divide component-wise. So the 10 over 30 gives me 0.33 meters a second in the I direction. And then 10 divided by 30 gives me 0.33 meters a second. Oh, squared, sorry. Meters a second squared in the J direction. So the idea is our acceleration is this. We're accelerating 0.33 meters a second squared this way and 0.33 meters a second squared this way. And so here's our acceleration vector, average acceleration vector. Okay, so again, you're going to do the Pythagorean theorem. That'll give you the hypotenuse. And then again, this angle has to be 45 degrees because the two sides are equal, right? So that gives us our acceleration. Okay, so that is that. I hope this was helpful.